We want to check convergence, divergence of the following series. It's very easy for me to compare this series with another series that you already know how to deal with. It is easy to compare this series with a known P series summation of 1 divided by n to the third. Why is that? Take a look. N to the third plus 8 is always more than n to the third. It's basic algebra. So if I flip this, I get 1 divided by n to the third plus 8 less than 1 divided by n to the third. Now I can use comparison test. Comparison test says if you have two series and if an is less than equals to bn, if the larger series is convergent, you can conclude that the smaller series is convergent as well. But the series 1 over n to the third is nothing but a p series. P is equal to 3. 1 divided by n to the third is a p series. P is equal to 3, more than 1, so we have a convergent series. So this series is convergent. Based on comparison test, we can conclude that the smaller series is convergent as well. So we conclude that the series on the left, which is 1 divided by n to the third plus 8, is also a convergent series based on the comparison test. So when you see series like this, jump into using comparison test. If you remember, a P series that is convergent or divergent, comparison tests help a lot. Let's take a look at this series. Is this convergent or is this a divergent series? Again, it's easier for me. It is easier for me to compare this series to a P series of the form 1 divided by square root of n. Why is that? Remember from algebra, square root of n minus 1 is less than square root of n. So 1 divided by square root of n is going to be less than 1 divided by square root of n minus 1. Now I can apply comparison test. By comparison test, I have the following. If I have two series and the general term of an is less than equals to general term of bn, and if the smaller series is divergent, then I can conclude that the larger series is divergent as well. So let us take a look. The series on the left-hand side is a P series. Here I have the summation of 1 divided by square root of n, or n to the power a half. This is a P series. P is equal to 1 over 2, which is less than 1. It means that, so the series is a divergent series. The smaller series is divergent series. So I can conclude that the larger series also divergent. So the larger series here, the summation of 1 divided by square root of n minus 1 is also a divergent series by comparison test. So this series is a divergent series. Let's recap what we did. My very first series is the summation of 1 divided by n to the third plus 8. And we saw that it's easier for me to compare it with a p-series summation of 1 divided by n to the third. Why is that? Because from algebra, n to the third plus 8 is more than n to the third. So 1 over n to the third plus 8 is less than 1 divided by n to the third. This is a p-series. This series is convergent series. And from comparison test, if the larger series is convergent, the smaller series will be convergent as well. So the series on the left also a convergent series. So by comparison test, we end up having a convergent series. I also gave you another example, the summation of 1 divided by square root of n minus 1. Again, it's easy for me to compare it with a p-series. Why is that? Because square root of n minus 1 is always less than square root of n. Please be careful about the domain as well. So if I flip this, I get 1 over square root of n minus 1, which is more than 1 divided by square root of n. Or if I write it nicely, neatly, it is 1 divided by square root of n less than 1 divided by square root of n minus 1. But from comparison test, if the smaller series is divergent, here you have a p-series, but my p is equal to a half, which is less than 1. So indeed, I have a divergent series. Comparison test says, well, since the smaller series is divergent, your larger series is divergent as well. The series on the right-hand side must be divergent as well by using the comparison test.